All right, so today we're talking about composite volume. So in Chapter 2, Task 2, we talked about composite area, which was just adding or subtracting multiple areas. Today we're going to do something similar. We're going to do composite volume. Same idea. We are going to add or subtract multiple volumes. So if you remember at the beginning of the semester, we gave you that formula sheet that has all of the formulas on it. This is just the volume section, right? So general prisms, so 99% of the time, this one is the one you're going to use. As a reminder, that capital B is there for a reason. It's the area of the base shape. So whatever the base shape is, if it's a triangle, if it's a circle, if it's a square, whatever, find the area of that and then multiply it by the height. Just as a reminder, and I think you should write this down, our area formulas, if you don't have your sheet from the beginning, a square or a rectangle is base times height. A triangle is 1/2 base times height. You don't have to have those memorized, but it certainly helps. If you see a cylinder, it's pi r squared h. Remember that r is the radius. A sphere is 4/3 pi r cubed, right, with a 3 up there. A cone is 1/3 pi r squared h, and a pyramid is 1/3 capital BH. Notice this capital B shows up again. It's still the area of the base, whatever shape is on the bottom of that pyramid. So here we're finding the volume of multiple shapes. If the shapes are next to each other, we are going to add their volumes together. If we are removing a shape, so if two shapes overlap, or if we're cutting something off, if we're hollowing it out, if we're leaving an empty space inside it, we are going to subtract those volumes from each other. So I just have some examples here. So I'll notice here, I can make a cut right there. You could also make a cut right here. That would also work out just fine. So I'm going to find the area of this. And sometimes it helps me to draw in that base, right? Because this base shape down here is what I'm actually looking for, right? The volume of a prism, which is what this is the area of the base times the height. The base is going to be 8 times 10, right? Base and height. And then I need to multiply that by the height of the whole shape. And I kind of scribbled it out here, but it's this 4 right here. So 8 times 10 times 4 gives me 320. And then I need to find the area of this. So I'm going to do this guy again. I'm going to try and find this thing. So now first off, I want to find this piece of it. I know that it's 3 centimeters from above here. Oops, centimeters. I need the length of it, and notice that this length is the same as this length is the same as this length is the same as this length. So this must be 10. And then when I'm looking at the height, I notice that the whole thing is 7, but I'm not interested in the whole thing. I'm only interested in this part. So I need to figure out how tall this is. So I'm going to look for other things that are the same height. It's the same height as this 4. So if this piece is 4 and the whole thing is 7, this must be 3. So the volume of this guy is going to be still capital BH. The base is going to be 3 times 10. And then I need to multiply it by the height, which is 3. And 3 times 10 times 3 is 90. Now I need to decide, do I need to add those two volumes together or subtract them from each other? These two shapes are not overlapping. They're next to each other, right? I know that when they're drawn in 3D, it can be hard to tell. But this second shape, the green one over here, that's the idea of something overlapping. They're literally inside each other. These two are just next to each other, right? One stacked on top of the other. So I'm going to add. 320 plus 90 is 410 centimeters cubed. Volume is always cubed, whatever the unit is. So I'm going to look at the next one. The next one, I have a prism from this guy, and I have a cylinder, right? This cylinder going back. So whenever I choose volume, I'm trying to look at base times height. I'm actually going to do the shape of this guy as my base. I could choose the rectangle at the bottom, but you don't necessarily have to. I usually say choose something that isn't a rectangle. So the volume is the area of the base times the height. The base is 25 times the height of this guy. I've got to look around for it. Is actually over here, right? The whole height is 25 as well. And then I need to multiply by how far apart these two shapes are, right? This height right here. It's 30, right? Those two shapes are 30 apart. So 25 times 25 times 30 gives me 18,750. And then I need to find this cylinder in the center here, and I'm going to erase some of my little coloring here. Formula for a cylinder is pretty straight up. The volume is pi r squared h. So pi is 3.14, or you could type pi into Desmos, which is what I'm going to do. The radius. Notice that the diameter is 8 centimeters, right? From edge to edge is 8. I only want from center to edge, so that's going to be half of 8, which is 4. And then the height. How far apart are these two circles? Well, it doesn't tell us, but it does tell us that the whole thing is 30. And if you'll notice that these two are parallel, they go the same direction, they are the same. So that must also be 30. So if I type all of that in, I have pi times 4 squared times 30. I'm just going to round to the nearest tenth place. It is 1507.2. And then I need to ask myself, do I add those two volumes together or do I subtract? Well, in this case, these two shapes are overlapping, right? I have this little rectangle-y thing right here, and then it's almost like I'm cutting out this center cylinder, right? They are literally inside each other. This is a subtraction problem. So 18,750 minus 1507.2 gives me a total volume of 17,242.8. All right, try and figure out what these next kinds of shapes are. My pen isn't quite working at just a moment, so I'm going to give you guys just a second to those, and then I'll put the answers up in the chat. So here I've got my Desmos calculations up. I started with a small cone. I noticed this is 4 millimeters, right? So each of these must also be 4. So if I look at the small cone, it is 1/3 pi r squared h. So that's 1/3 times pi into the radius, which we already said before, squared, and then the height, which is 134.0. On the big cylinder, 1/3 pi r squared h is silicone. But I notice that this piece is 4 and this piece is also 4. So the radius here must be 8 from the center to the edge, where I got that 8 from. Then I need the total height. And know this piece of it is 8. The whole thing is 16. So I get 107.3. Now, these two cones are the definition of overlapping. This shaded in cone is inside the cone. So that is a subtraction problem. So I need to take 1072.3 and subtract out the 154.0. Give me a total volume